Hello friends, welcome to another exciting session on this network theory. I, Prof.Darshan Thakur from Terna Engineering College, Dharashiv, welcomes you on my YouTube channel for this subject head, network theory. So friends, as far as this session is concerned, so we will try to discuss the second methodology in case of this node analysis, whose name is nothing but the supernode analysis. So similar to the super mesh analysis, most frequently this technique is being also used in order to realize the given network in terms of certain voltages or currents, whatever it may be, based upon that particular objective, right? So here, as you can see, such type of network we are having with us. So in this network, as if we are interested to determine the current flowing through this 2 ohm of resistor. So that will be the objective set for this session. If by using this supernode analysis technique, we need to determine the desired current flowing through this 2 ohm of resistor in that network. So first of all, carefully we need to look around to this given network. In this given network, there are energy sources and few resistive elements we are having with us. Now, as far as energy sources are concerned, so I think we are having three voltage source with us. One is of 10 volt, a DC voltage source, a 20 volt, and third one is nothing but what, 5 volt. Again, we don't have any energy storing devices because basically this network falls under the category of pure DC network, right? So in this DC network, we need to determine the current flowing through this 2 ohm of resistor. So already we had discussed one numerical based upon this nodal analysis, or at the end of this lecture I will give you the desired link for that previous lecture. So at that time already we had tabulated or already we had realized the given network in terms of node analysis, right? So as we know, node is nothing but what, the point at which multiple number of branches are interconnected to each other. So whether it is node analysis or super node analysis, first step which we need to do from this network point of view, we need to determine how many number of nodes we are having with us, right? So as you can see, this is our ground node, right? All the lower terminals of these branches are are connected together to this same potential, that is nothing but what, 0 volt. So all these lower end of these branches can be called it as a ground node, right? So apart from this ground node, see, this is the first node of that given network, and this is the second node of this given network. So the potential which is lying at this first node can be called it as a V1, and here this potential can be called it as a V2. So V1 and V2, these two are the node potentials, right? Then after that, what we need to do, we need to apply this Kirchhoff current law, which says that the algebraic sum of incoming current plus algebraic sum of outgoing currents equals to 0, or summation of incoming currents equals to summation of outgoing current at that particular node. So the basics of Kirchhoff current law, right? So from sake of observation, what we need to do at this node potential V1, there are three branches which are interconnected to each other, first one, second one, and third one, right? So first of all, we need to assume the direction of currents, like this will be I1, this will be I2, this is I3, right? This is I4, and this is nothing but what, I5, like this, right? Then after that, what we need to do, we need to apply this Kirchhoff current law at node number 1 as well as node number 2. But see, the unique identity of this supernode analysis is nothing but what, carefully you just try to see, in between these two nodes V1 and V2, we don't have any resistive element. We are having only one battery of 20 volt, a voltage source we used to have, which is interconnected in between these two voltage source in absence of any resistive arm, like this. So V1, V2, and this is 20 volt of battery, right? So whether it is V1 or V2, for V people it is not possible to apply the Kirchhoff current law to this particular branch, which consists of only voltage source in absence of any resistive element, because according to that Ohm's law, I equals to what, V by R, right? So we don't have any resistor which belongs to that branch, so it is not possible for V people to adopt the basic strategy of this Kirchhoff current law. So whenever such type of scenario we are having with us, so at that time what we need to do, so at that time virtually we need to eliminate this branch in which we are having only voltage source which is connected in between these two which is connected in between these two nodes, right? So this particular branch is being eliminated. As a result of elimination, what will happen? There will be a formation of this supernode, right? So to this supernode, all these branches are interconnected like this, right? This is nothing but what I1. This branch belongs to I2. This branch is being eliminated. So obviously this is nothing but what? This 3 ohm resistor branch I4, and this is nothing but what? The branch associated with this 4 ohm resistor as well as this 5 volt of battery. So this is how your circuit will look like. This is branch current I5. So I1, I2, this I4 and I5. How many branches are associated with that supernode? 1, 2, 3 and 4. And the direction of all these branch currents are considered as a outgoing from that node, right? And at that particular moment, we need to apply the Kirchhoff current law at this supernode scenario. So as a result of this, we will come to know that there are how many branch currents? I1 plus I2 plus I3 plus I4 equals to 0. So this will be the current equation at this supernode, right? The moment at which this branch is being eliminated, in which we are having only one voltage source as a part of supernode analysis, there will be a formation of supernode. To that supernode, all the branches are associated with each other. So there are 1, 2, 3 and 4 branches are there, right? So accordingly we can assign the desired currents like I1, I2, I3 and I4, or I1, I2. This I3 is nothing but what? The current flowing through this 20 volt of particular branch. So at that time, that can be rewritten as a I1, I2 plus I4 plus I5 or I3 plus I4, whatever it may be, right? But cumulatively, we need to add the 4 currents belongs to these 4 branches associated with that supernode, right? So the current equation will become what? I1 is nothing but current flowing through this 1 ohm of resistor, basically. Okay friends, so by considering the concept of this supernode, this is how our network will look like, right? So this supernode, which includes the potential of V1 as well as V2, right? Because as far as these 4 branch currents are concerned, out of that 4 branch current, I1 and I2 associated with this node potential V1, and as far as this I4 and I5 are concerned, this I4 and I5 are associated with this node potential V2, right? So virtually the supernode which consists of these two potentials V1 as well as V2, right? So the current equation for this I1 is nothing but what? I1 is nothing but the current flowing through this 1 ohm of resistor, right? So how this 1 ohm of resistor is connected? It is connected like this. This is 1 ohm of resistor, this is 10 volt of battery, and this is ground node, and this potential is nothing but what? V1. So according to that Ohm's law, I equals to V by R. So this V minus, we need to map the potential of this battery is how many volt? 10 volt, right? The direction of current is outgoing from this node, right? So due to this outgoing direction, V1 minus 10 upon 1. So this will be the current equation for I1. So it will become V1 minus 10 upon 1. What about this I2? I2 is nothing but what? It is the current flowing through this 2 ohm of resistor. It is connected like this. This is 2 ohm of resistor. This is V1. This is ground node, and again the direction is outgoing. So due to this outgoing direction, V1 by, because I equals to V by R, so plus V1 upon 2, right? This is a 2 ohm of resistor. Now what about this I4 and I5? As I told you earlier, I4 and I5, these two branch currents associated with this node potential V2, right? Now virtually, as this branch is being eliminated, so this supernode, at this supernode, we need to consider the potential of V2 instead of V1, right? Because I4 is nothing but current flowing through this 3 ohm of resistor. How it is connected? It is connected like this. If suppose this is the supernode whose potential is V2, this is 3 ohm of resistor and this is ground node. So according to that Ohm's law, it will become V2 by 3 plus what about this I5 fellow? I5 is nothing but current flowing through this 4 ohm of resistor. It is connected like this. This is the super node 4 ohm. This is 5 volt of battery and this is ground node. The direction of current is outgoing. That's why this V2, as we are going from negative plate to positive plate, opposite sign we need to consider. So it will become V2 plus 5 upon the value of resistor is how much? 4 equals to 0. Then after that simply we need to simplify this equation. As a result of simplification we need to collect the terms belongs to V1 and V2. So how many terms we are having belongs to V1? 1 plus it is 1 half, right, plus how many terms belongs to V2? It is 1 over 3 plus 1 over 4 plus remaining term is 5 by 4 equals 5 by 4. Again this minus 10 equals to 0, right. So this equation will become V1 into 1 plus 1 half plus V2 times of 1 by 3 plus 1 by 4, and this term is being shifted to the right hand side. As a result of shifting it will become minus 5 by 4 plus 10, right. Now this is equation number 1, right. Now in order to have the equation number 2, because see ultimately as we are having two nodes means we are having two unknowns means we are having two equations. So with the help of this scientific calculator we can solve these two equations. So in order to get the second equation, carefully we need to consider this branch in which we are having this voltage source of 20 volt in absence of this resistor. How it is connected? Again one more time I will draw. This is V1, this is 20 volt of battery, this is positive plate, negative plate, and this is V2, V1, V2, and this is 20 volt of battery, right. So according to this connection, when we apply this Kirchhoff law terminology, so the equation which we are getting, because this V1 belongs to positive plate and V2 belongs to negative plate, so it will become V1 minus V2 equals to 20 volt, and this will be your equation number 2. Now we need to solve these two equations, right. After solving this equation, ultimately V2 can complete our objective is nothing but what? To determine current flowing through this 2 ohm of resistor by using this supernode analysis. So I just hope you had understand all these steps belongs to this supernode analysis. Thank you. Okay friends, so these two are the equations. V1 times of 1 plus 1 by 2 plus V2 times of 1 by 3 plus 1 by 4 equals to 10 minus 5 by 4. So if we simplify this equation, so this equation will become 1.5 times of V1 plus 0.58 times of V2 equals to 8.75, and equation number 2 is V1 minus V2 equals to 20. So when we enter these two equation coefficients with the help of this scientific calculator, so equation mode there are two unknowns, so the coefficients are nothing but what? 1.5, 0.58, 8.75, equation number 2 coefficient 1, minus 1 and 20, right. So 9.78 is nothing but what? V1 and V2 equals to minus 10.21. So once we are having V1 and V2, then V2 can determine current flowing through any resistor. Thank you.